So I want to ask you a question, since I know that all of you in this room love data. But can you quantify how much value is within the data you're actually working with? Like this. So, can you quantify how much data is within the data you work with? Because I cannot. But here's the thing. Every time I get a question at work, I analyze data in order to answer it. And by doing that, I realize that I actually create value. But knowing that insights can be derived from data and people can actually improve their understanding on the things they're looking for, to me, feels amazing. My name is Evangelia Soultani, and I work as a data scientist at Volvo Group Connected Solutions. And today I'm going to share with you how do I get the most out of the data I work with at Volvo, but also show you that the data you have are probably more valuable than you might think. But before we start, I want to make sure that this is not going to be a corporate presentation at all. Woohoo, yes. So let's start with some facts. Of course, 90% of the data we have today in the world have been actually generated over the last couple of years. And to me, this is just crazy. But at the same time, Volvo Group has 900,000 connected assets in the world. And they will still become 1 million. And you probably know those assets. We talk about buses, trucks, construction machines, drive lines for other industrial applications. Yes. So all those data generated from those big connected assets, all those assets generate a lot of data, of course. But how does really Volvo uses that data? And I would say that this is where data science comes to place. Because our mission is to unleash the value that is contained in this data by using advanced analytics and visualization techniques. And as I promised, I will tell a story of how I work with data in Volvo Group and how I get the most out of it. So, topics for today. I will briefly explain what type of data do we have at Volvo. And then, of course, explain what is the process we follow from the moment the data are generated until we actually are good to use it. Then how can we overcome the challenges that we face? Then talk about how do we really condense the information contained in the data? How do we generate features with a manual or automatic way? And then how can we actually enrich the level of information we have about our data by combining them with other additional sources? So I will start with this comic because I think, I think this is how people think of us. People who don't work within that field. They feel like we are sitting on this pile of data and maths, maybe. And we are not sure exactly what we do, but we have the data and we have the models, and we steer the data so that we can get something out of it meaningful. But of course, that's not how we work. For example, me. How do I spend my time? Where do I spend my time? I usually focus on those 5 aspects. Of course, we need to have a well-defined problem. We need to have prepared data. We need to have some kind of models and algorithms. Then analyze this outcome and validate the methods, and finally get the insights. And I think that all of them are equally important because they are to some extent interconnected. If we don't have the right data, for example, for the right problem, it doesn't matter what we do, it will not have any value. And since I will focus on the data part today, I want to stress out how important it is to have well-prepared data for the specific problem we want to solve. Because when we don't care about the data, and as also the previous speaker mentioned, we treat them as garbage, then what we will get in the end will be garbage. But right, what data, what type of data Volvo has? And why do I mention here legacy data? Well, simply because we weren't born digital in Volvo. Volvo builds on 90 years, almost 90 years of history, and that means that the company has been through a lot of transformation, digital transformation through these years. And that's why we have legacy data. And of course, yes, those data, as I mentioned before, come from different products, which means that in one sense, they're quite diverse, and in the other sense, they are quite complex. You can see this vehicle here, and you can imagine that a lot of data are generated from it. There are a lot of components inside, which include signals. For example, how much fuel the vehicle consumes, how it's used. Data could be also location, could be also records from maintenance, and so on. So they're quite diverse. And Volvo started collecting data around the 90s. And this is great for us because we have a lot of data to work with. But at the same time, since this time has passed, a lot of things has changed on the way, which means that sometimes we need to really interpret the data we have available. And one good thing is that since we have a lot of history, we have a lot of people who have the competence within the company. So it's always, what we always do is we always reach out to people who have the domain expertise. But when it comes to new data and new ways to collect information, this can be a challenge because, of course, we need to make sure that whatever we do, it should not disrupt the existing infrastructure, platform, hardware, software that is in the vehicles, and of course the customers who actually use it. So we should always keep that in mind. And another thing that is super important is the process of how we generate the data, which is actually quite a complex topic. And I will give you an example. Imagine that there's a customer somewhere in the world and wants to own a few vehicles and would like to realize, okay, under which conditions those vehicles I own do they operate? So in the simplest scenario, we would probably need to have a sensor that measures the temperature. Yeah. So how hard can that be? All we need is to analyze the data from the sensor. But in reality, that would be slightly different because, of course, the sensor is placed in the vehicle. And the data that it generates are transmitted to other components. Maybe it's not one component, maybe it's more. And finally, there is a telematic unit, which transmits the data, splits them, cleans them, and so on, places them in a database. But maybe that's not the final database because we have more, and we reach the data warehouse. So this is us sitting in another place in the company, and we finally get the data to analyze. And of course, so far we talk about raw data. We need to clean them again. We have to process them, apply our models, get the insights, maybe come up to a point where we develop a solution, and we give it to the customer. So, oops, sorry. I'm going back. Yes, so as you can imagine, this is a really long process, and a lot of things can go wrong on the way. So we should always be aware that how we treat the data we have available. as I said, it might seem overwhelming, but since there are a lot of steps on the way, but it's also an advantage to some extent for us because we're always questioning what we work with. We have to make sure that whatever we use, we really understand what it really represents, what this sounds reasonable for us. And that means that sometimes we have to consult domain experts, which is fine. But yeah, so far I talked about raw data. But of course we know that when we work with data, we don't really directly use the raw data. What we want to do is to somehow condense and extract and condense the information contained in the data into something more meaningful in order to actually use it. I will give you an example. Imagine that we want to have to build an understanding of how vehicles move within Europe, and try to understand, try to see on a high level if there are any patterns, any regions where we have a little bit of more density. So all in all, maybe we want to somehow quantify the flow of the vehicles. So how should we do it? If we start by using the raw data, which in that case could be, for example, GPS locations, I would think that that wouldn't really work because, first of all, it's a lot of data. And second of all, using all GPS locations doesn't really capture what we want to achieve here. So maybe there's another way to do it. What if we focus, for example, on the routes? But how should we do it? We could actually group the data we have and group them into hubs. This, hope you can see, these blue dots here. And those hubs represent the most frequent stops. And then we can create a network. So in that network, the links, the blue lines, represent the different routes that are generated from the vehicles that are passing through those nodes. So suddenly, we start, even though it's still messy, we start to see some patterns. And that's, I think, that's the beauty of having, of aggregating on our data and condensing the information. But, and to some extent, another way, and one way to do it is to generate features, which are basically, again, more meaningful representations of the data we have. And I'm going to talk about two different ways to generate them, manually and automatically. But before that, I was thinking of what picture should I show you in order to represent this topic. And I couldn't really think of something, but well, the first thing that came to my mind was this Rubik's Cube. Because if you think about how do you play that game, you usually want to turn the pieces somehow so that you end up in this, I can use it now. Yeah. So in this result where each side has one color. But you have to try many, many, many times, which basically it's what happens when you try to generate the features. It's not, well, I would say it's highly unlikely that you will get the best features with your first try. You have to iterate. And at the same time, when you play this game, every time you start again, you don't necessarily start from scratch because you have some kind of experience of, okay, what I did before was not really good, but now I have another strategy. And it's the same when you try to generate features because you wouldn't really, the more familiar you become with a topic, with a domain that you're really trying to work with, the better features you will finally generate because you know more about it. And what characteristics do features have? The most obvious one is that, of course, they are derived from the data we have available. And then, of course, it's relevant to the problem we want to solve. And ideally, they contain some kind of condensed information, as I explained with the example before. And it should be possible for us who work with data to interpret them. Maybe not for the rest who use it, the end result, but for us at least, we should know what we are defining here. And finally, and hopefully, what we chose is not correlated with other, with the rest of the selection we have done. And of course, the better the features we define, the better the outcome would be. So, yeah, as I said, the first way we could do that is to sit down with our team, for example, or ourselves, and try to come up with features that are relevant to the problem we want to solve. And of course, that sometimes requires some kind of human intuition or even domain expertise. Depends on how complex the topic we want to solve is. And that can be a process that can take time or not. Again, it really depends. And one challenge with this is that it could actually, to some extent, be affected by our bias and our current knowledge on the topic. And I will give you an example of a feature we have defined in my team. So what you see here, is a map of Sweden, half of Sweden maybe, and on top of it is a pattern of a vehicle moving around. And what we want to come up with in this case is to find a way to describe how the vehicles move on the map based on GPS location, for example. In that case, could be we would like to know if that vehicle, for example, drives long distances or fixed routes, or maybe from A to B. I don't know, but something like that. And if we try to use directly the road GPS data, again, that wouldn't really work because it doesn't really capture what we want to achieve. But what if we use the distribution of those positions combined with the movement pattern of that movement, of that vehicle? And then once we do that, we aggregate that information and we end up with a number which tells us how the vehicle moves. But sometimes it's not so trivial to come up with, define a feature by ourselves. So what we need is to find another way maybe to automate the process, have a program that does it for us. And again, this is an example of an automatic way to generate the features done in my team. And for example, we have different variables here, fuel consumption, acceleration, and so on. But we don't know really how to use them to solve our complex problem. And one way is to query the data and apply different aggregation operations on it. So that will give us basically a way to work with. We query the data and yes, we query the data and then we perform the aggregations. We apply those to the models. We get some results, and we finally assess the features we have defined before and rank them based on their importance to our problem. And in the end, we select those that we believe in. But of course, we don't stop there because we have to iterate and iterate a lot of times until we feel confident. And yeah, I said that. And of course, it's quicker than the previous method. And it explores faster and more extensively the feature space and can be reused. Yes. So what we said is that we start with initial variables we have, and then by automating that process, we explore more of the feature space. But sometimes we have those strange combinations that we cannot really generate through automation. And maybe in those so unlikely combinations, there will be something that is valuable, and maybe that's what can be defined by domain experts. So we need to be aware that maybe a combination of both methods can actually be super helpful. But of course, we shouldn't stop here, because as I said, there is more value in our data. And how we can get it is by, for example, looking into additional data sources. And I will just quote what Aristotle said at some point, that the whole is greater than the sum of the parts. And I think that this concept applies really well here, because if you think about it, sometimes only when you combine data sources, you finally get to the point where you will see these insights that you wouldn't be able to see if you were analyzing the data separately. And again, I'll give you an example. What you see here is different vehicle models, excavators, loaders, and so on. Each vehicle has one color, and then the size of it indicates how many they are. And on the x-axis, you have the time. So we see how the distribution of vehicles progresses over time. And it's useful information, but it kind of seems out of context, because what if we start to combine that information with the location, for example? Knowing in that case that maybe this place is a construction site, can I see how the work progresses over time based on that? Based just on the data we have. And maybe now our data gives us a little bit more information. Maybe we can see the different phases in construction. In the beginning, we have to clear the site. We have to remove all the dirt and the rocks and so on. And maybe later, the excavation part starts to take place. And in the end, they start to build the foundation. And that's one way, because we have used our data to explain the location. What if we now take the information from the location and we feed it back to our data? So now we know, for example, that those vehicles are construction vehicles. Maybe if we analyze the behavior, we will get a bit of more understanding about those construction vehicles. How are they used? How much fuel? Do they consume a lot of fuel over time? Do they have frequent stops and so on? And I will summarize now, because I just want you to remember those few things that I mentioned, that we need to have the right data for the right model, making sure we have prepared them well, be aware of the cycle because it can be quite complex. Same time, better features, better outcome. We should combine domain knowledge with automated techniques, but don't forget the domain expertise. And in the end, think about enriching your knowledge on the data by looking into other data sources. That's all. Thank you.
Okay, thank you very much, Evangelia. Any questions from the audience? Everyone there? And here as well? Okay, we'll start here.
Hi, I was very interested in your automatic feature generation. Have you tested some different frameworks for that?
Sorry?
The automatic feature generation.
Yeah.
Have you tested any different frameworks or tools for doing that?
No, we just, as I said, we just use SQL queries, and then we used Python as a framework.
All right, excellent.
That was
Thanks.
all. I was just, for us, we haven't really made it as a anything yet.
Okay, we have a question over there.
Yes, hello. I have a question. When you do sort of the feature, when you look into the different features, I'm thinking you can look at what supervised and unsupervised, and I interpret this as very much an unsupervised operation. I may be wrong, but I'm thinking when you do that type of inquiry, how do you work with? Where do you set the limit and say, okay, this is just a waste of time. We're not going to find anything else here. How, if you understand the question?
Yeah, I think it really depends on the problem we want to solve. Of course, there should always be a point where we said, okay, it's good enough now, we should stop. And I think that varies, depends every time on the problem. Yeah, I don't know how to really put it into.
So it's from case to case.
Yeah,
based.
and also the more familiar we are with the thing we want to really solve, the easier it is for us because we build this competence and our intuition increases.
Right. All right. Thank you.
One here as well.
Thank you. I was wondering, is it more common that people come to you and ask for questions? Do you have the data to be able to answer this question? Or is it more that you explore the data and then contact the people that might use the conclusions that you can draw?
I would say it's both, because sometimes people within Volvo, for example, might come and with a very specific question, and then we work on that. But there are other cases where we try to become a bit proactive, and I spend some time on this exploration phase without having a specific requirement, because we know that there might be a need and it might be helpful. So
yeah,
it's a mixture.
I can imagine that having the possibility to explore the data on your own more freely can give more insights as well.
Yeah, it can. And it's the same data. I mean, it could be the same data that could we reuse and reuse, but in total different ways that will give us total different answers. So,
thank you.
Okay, thanks. Great questions, great talk. And now we have 1 hour lunch. Go out and network talk. See the exhibition. Have a nice time. And we'll meet back here at 1 o'clock. For those of you who want to come. We have some very interesting talks then as well. So, one last applause for Evangelia.